Hello, hello. Welcome to episode 3 of the Code Katas for Terminal Bash. Let me just go ahead and plug this in here. So in this code kata, we've got a choice here between a couple of different katas. Just a moment. Cool. Dog decided now is definitely the time to go outside for the restroom. Okay, so we've got a couple of katas here. We have one, consider the word Adobe. A is in position 1, B is in 2. And in the alphabet they're in the same position, so on and so forth. So we can determine how many of these words have their letters in the right area. Case insensitive. Or is it case sensitive? Looks to be... Well, hang on. So there are 3. Position 4. Okay, given the array words, return an array the number of letters that occupy their position in the alphabet for each word. Okay, so word, list. So it's like variadic. Yeah. So, and then there's this one. No story, no theory. A cum should self-declare. Looks like A has 1, B has 2, C 3, D 4. 1, 2, 3, 4, 5, 6, 7. Easy. Let's do that one. Alright. So, put our kata from last time. And we'll make a directory called mumbling. And you know the drill. We're going to touch kata test.go and kata.go. And we're going to do test-driven development. Kata test first. Paste this in. And again, I'm just going to use testing because I do table-driven tests. So what we need basically will be a struct. So we're going to call this mumble tests. It's going to be global or package level var. It's going to be a slice of structs, and those are going to be, there's going to be an in struct, and it's going to, actually it's just going to be a string, and we expect an out string. probably one of the easiest structs that we've built. In, out. And we're going to do 3, 4, 5 of those. Okay. We're going to, actually, let's do this. Q, Q, delete inside of this and move down. We're going to do that for at Q. Okay, so delete inside of this and paste. Okay, and then I need to turn some wrapping off in Vim. So let's look that up real quick. Vim turn wrapping off. Text width. Set text width to 0 and margin to 0. We're just going to do that here. We'll say disable wrapping. And then I just want to find text width. Where else? How about wrap margin? Okay, we're good. Okay. There. That didn't seem to do the thing. Okay, we'll start with that. So now if I go to the end of this, yes, exactly what I want. Okay, so just turn text wrapping off. So we'll go to line 26, and we'll delete inside of there, go to line 11, paste, go to line 27, delete inside, go to line 12, paste, go to line 28, inside, 13, paste. There we go. 29, 14, paste. Okay, so we've moved all of our tests over, and they've got this. We're just going to say test mumbles. And then inside of here, we'll take MT from testing. Okay, for value, we'll say test, and from the range of mumble tests. And then we're gonna, so these all have a very similar, what do we, oh, so I need, comments on all of those. Yep, okay. Alrighty, so at this point we always go back over to kata.go. And we take our code from their solution, paste it in. On line 1, we have to get rid of test. So they share a package name, so that line 1 in kata.go, line 1 in kata.test.go. Okay. And so we know that we're going to return a string. So here we can start to test this and see that we're failing. But we're failing for a different reason. Test was not used. So for now, we're just going to do 2 underscores. I'm not happy with that. Okay, so if test is nil, say this. T dot error fatal expected the string got the string, and this is going to be test dot out and got the result of a cum, which I'm going to I'll leave it. I think I'll have to leave it. So you're going to expect that. Maybe not, but we'll see. So basically, result is equal to a cum, and what does it expect? Just test dot in, and then so it's going to be if result is not equal to test dot out got result. Everyone's happy. Tests should be passed. Or, well, tests should work. They should fail, but they should work. Oh, passed. That doesn't seem right. For test result, if result does not equal test dot out. Yeah. There we go. Okay, so expected these, got nothing. Perfect. Alright, so basically for, we'll say the index we don't care about, and then the rune. See how rune is a keyword though? So string segment in the range of S we are going to care about the index actually. We'll do I for index here, and then alright, so basically for the length of I, or the loop of I, we need to append okay, that'll be interesting. Append segment amount of times if it is not the last iteration, add a dash, right? So the kata says, and really it's not even about the katas at this point, it's about this. You know what? We can actually just create a bunch of them as slices. Oh, and the capital one, first one is capitalized, which is easy. And then join them together. Then I have to have slices for each one. So then I have to have like a struct of slices or something. I'd rather just append the dash, to be honest. Okay, so for yeah, sure. Well, people do J, right? In index loop you know what, we could just do j is equal to 0, j is less than I, so if I is 0, j is 0, less than or equal interesting. You just say I plus plus. So if it's 1, we'll increase it. And then let's go to the playground. So we've got I is equal to 10, and then we bumped print the length of 10, 10 being I, undefined I. The argument, yeah, exactly. So, okay, that's fine. So it's increasing. We'll trim it off at the end or something. So we're in here and we have our result. So notes the first loop. So first letter is going to be the segment. So we're going to need strings. And then let's look up Golang strings. And we want like upper to upper. So we'll say strings dot to upper segment. If j is 1, we'll say, I guess we could do it here. Result plus equals string to upper. Otherwise, we just have the regular result. We get done with it. We get done with it and we append. To the end of this, a dash. Unless it's the last, and how do we determine that? That's the problem. We would say if I is equal to hang on. I is the index of the first segment. Why is it angry? Okay, it's not. Why is it angry here? Oh, right. Okay, so why is it angry here? Can I use rune? Oh, because the segments. Okay, so reassign as a slip. Okay. Okay, so what I did there is I reassigned segment as a string. Segment came as a rune, because if you range over a string, and S is a string, right? If you range over a string, then you get a rune out. So I just recast the rune, which was segment, to segment, and cast it as a string. Then we increase I, increase J. If J is equal to 1, do the thing, string upright, continue, otherwise go there, and we do it for up till I. And I might not need to do that. I might be able to keep this 0 indexed. Okay. Pin the segmented amount of time. So the real thing is getting sort of the end of all iteration. So we know, I mean, a string itself should have a length, right? So length of ABC should be 3. So let's just do it. If the length of S is equal to I plus 1 is not equal to I plus 1, then we'll go ahead and add our result. Okay, so let's go ahead and test that real quick. Alright, so, we need to return the result. Okay, we're not doing very good here. So let's look. If I is equal to 0, add it. Otherwise, we just want to add the segment. So for the first loop, this is, okay. CPG. Oh, it's not, yeah, 2. Okay, so index represents the rune position. Okay, so just replace all J's with I's, just to make it a little simpler. So we loop through, and is I, which is 0, equal to the rune position, which is 0? Well, yes, it is. So what did we get out of it? We got Z and M. Continue. Okay. And then it's equal. So if it's not equal to the rune length of S, so we should see dashes, which we do. Okay. Then we go through. Rune position becomes 1. And so 0, I is equal to, so 0 is equal to 1, which it is not. So increase it's not I, well, I is 0, so it's the first. So then here we should append the segment, and that's the thing. So that would be P, and we're not seeing that. We're just seeing dashes. Help me out, guys. What am I doing here? So let's do some stuff. Bring in Frontier. We'll just print out a couple of things. Print out I and rune position. Does that work? Yes. 0, 0, 0, 0, 0. So let's print out the length. Wait, rune position 0. Okay, 0, 1, 2, 3. Okay, that makes sense. And make sure. Yep, there's 10. Oh, I'm being weird. Less than or equal to. Okay. Good news. There we go. Okay, so got Z, BP, GG, LL. Oh, my U's are all capitalized. So we're close. Oh, I is equal to 0, less or to equal to rune position. So close. My R's are doing it as well. Weird. QENU. It's universal. It's doing it in the same place. 1, 2, 3, 4, 5, 6 iterations in. It's thinking I is 0. What? How does that make sense? Oh, it's because they're already large, so 2 lower segments. And then strings. Okay, and now we work. There you go. Okay, so am I happy with this? Oh, yeah, that worked. Totally worked. So I declare a result once, and I populate into it, and then I append to it, upper or lower, depending on it. I'm doing an extra transform. I'm going to be fine with that, personally. And like, I could do an else here, but personally, I like to see a return early. I mean, it's not like, so I'm 25 lines total here, and I'm 25 lines total here. So I'm just going to keep my continue. So So I've got a 4 out of 4, which is pretty nasty, but I don't really have much choice because that's what it demands. So I'm going to call this good, right? So let's go back to our kata. We'll paste in our solution, sample it. Samples passed, we'll attempt it, and it's done. Submit. Alright. And that's it. I mean, that's pretty straightforward kata. Wow, look how sweet and simple his are. Oh, that repeat, which it's a for loop. Like, it's a glorified for loop, right? I need to, so he's got parts. You made a slice of string length of s for length of s. Puts it in parts. Title and repeat. Is this best practice? Just to use that repeat? Yes, it is. Let's see. Repeat. Everyone's repeating. Everyone's repeating. Less than 96. I'm not sure what's going on there. I'm gonna ignore it. And then he just slices, chops off the end, which you certainly can do. Strings repeat to lower, upper, whoa, whoa. Okay. Pulled in strings. That's hard to read. S out plus equals upper, slice. Oh god, no. Strings repeat. Strings repeat. I don't know what they're doing with these. I'll have to. I could come back to it later. Let's get a for if. So he does his if check here. He's got this bytes buffer. It's probably a cleaner way to do it. And then he just trims off at the end. Yeah, I mean, they all do the thing. It's so interesting to see how many different ways people write this. He did pretty much what I did. Upper, lower, result, trim. I didn't trim. See, he did this. This is probably the best I've seen. Super clean. Other than the one that uses the bytes, the buffer, that's probably technically more sound. Cool. Or if else, return. Whoa. Not sure what he's got going on down here. Okay, that's where I'm going to leave it tonight. Thanks for watching. This was episode 3. This was a really, really easy one. I'm going to try to do these more often. We'll see how often I can do them. Alright, see you next time.